So like I said, we're just going to be solving exponential equations using common bases. Basically, the big idea is if you have an equation like 2 up to something equals 2 up to something, you can basically get rid of the bases and set the exponents equal to each other. So your goal for pretty much all these problems is basically for like number one, if you have a common base, remember a base is what you're raised into a power. Remember, it's like your base is whatever you have up to your power. So your base is like the big number. So basically for like question one, you have 2 up to x plus 1 equals 2 up to the ninth. Basically, you can kind of just cross out the bases and just set the exponents equal to each other. So then, I mean, this is a very simple equation. When you subtract 1, you would get x equals 8. I mean, or just, I mean, if you thought about that, I mean, pretty logically, if you plugged in an 8 for that x, of course, you're going to get 2 up to the ninth. I mean, so, I mean, you could probably kind of eyeball a pretty simple one like that. And these are kind of our steps, but basically your goal is to make it so you just have something up to a power equals something up to a power. So sometimes you might even have to use some of those exponent rules to kind of combine, like if you have like two bases times each other. But like I said, for these first few, like basically the big idea is if you have it in this form, they're the same base up to an exponent, you can just get rid of the bases, set the exponents equal to each other. And this only works if you have the same base. So if you had 2 up to something and 3 up to something, well, you can't do it unless you can rewrite it in common bases, which we'll see in a bit. So I mean, like these are pretty basic equations. I mean, you could just get your n's to the same side, get your constants to the other side. But you would get n equals -4. So like for examples 3 and 4, though, like I said, before you get rid of your exponents, you kind of want to combine, like if you have more than one base on a side. So for example, remember, if you're multiplying things with the same base, you can add the powers. So if you added these two exponents, you'd have k plus k, that's 2k. And then that plus 2 just kind of comes along. Then equals 3 up to the 5k minus 1. So you could just get rid of the bases. I wrote a little bit too big. But you'd have 2k plus 2 equals 5k minus 1. Then if you solve this, sorry, I wrote, actually maybe I'd do the other way. I'll subtract the 2k and add the 1. Sorry, I wrote way too big, but you should get 3 equals 3k. And then k would equal 1. Sorry, that's a little bit sloppy, but basically just solve that pretty basic equation. Nothing too crazy going on there. So same idea here. I don't think any of the problems in Delta Math are actually going to be like that. I'm pretty sure in Delta Math they're already combined, but just keep in mind if you have more than one piece, you could kind of combine them together. So like in this problem, if you added your exponents, you'd really have 10 to the 5th on the left side. And on the right side, if you added your powers, you would have 3b, would that be minus 7? So then if you set 5 equal to 3b minus 7, you could add the 7 over. You would get 12 equals 3b. You could divide, you would get 4 equals b. Any questions so far? So basically, if you have the same base, you can just kind of drop your base and set your exponents equal to each other. But sometimes you're not, and pretty much what you're going to see in Delta Math, all the problems you're going to see is you're not always going to have a common base, but if you can rewrite your equation with a common base, you can basically do what we did in these first 4 examples. So you're definitely going to want a calculator handy because you almost need to do a little bit of guessing and checking to kind of see what maybe the common base would be. But for example, so this number 5. So I can't, like right now, I mean, and keep in mind, this is really 36 up to the 1st. I mean, I can't just cross out my bases because they're not the same. But is there a way I can write them with the same base? Like you might want to ask yourself if there's a base, I could write something up to something that equals 6 and something up to something that equals 36. So for example, in this problem, I mean, if I just keep this 6 as my base, I could rewrite 36 as 6 up to the second power. So now these have the same base. And this can be a little bit tricky. Sometimes it might be hard to kind of figure out what your common base might be, or you might have to do a little bit of guess and check in. And some of the problems in Delta Math are kind of tricky, so we'll see how it goes. There's a level 1, level 2, and level 3. Level 3 might be a little bit crazy, but I still wanted to maybe see if you guys could do it. But then once you've got the same base, you can get rid of your base, set the exponents equal to each other. So I mean, then just solve this basic equation. Get 6. And you could always plug this back in and check to see if it works or not if you want, but that's up to you if you're motivated. So for example, number 6, I have 2 up to the p minus 7. One kind of tip, it's not always true, but a lot of times if you have an even number on both sides, a lot of times you can write it as 2 up to a power. So you're kind of asking yourself, 2 up to what power equals 8? If you don't know that, I mean, some of you guys, hopefully it's not that big, maybe you see it, but if not, just plug in your calculator, like 2 squared is 4. If you plug in your calculator, 2 up to the third power, that is 8. So that is actually it. But, and if you don't know how to put like a different power in your calculator, I'm assuming you guys all do, but you want to use the caret button. Most calculators have like it's called the caret button, and then just put whatever power, but just kind of plug and chug until you get it. But 2 to the third would be a way we can rewrite 8. So we have the same base. So then we can just set our exponents equal to each other, and our answer would be 10. Let's see, let me know if there's any questions. Nothing yet. Okay, so on the back side of this sheet, or on the second sheet of this PDF, I pulled some problems from Delta Math because I thought their problems were a little bit trickier than what I had in my notes when I did this. So we'll see how this goes. I mean, if it's a little bit rough, like I said, honestly, this isn't the most important topic in Chapter 7, but I wanted you to see this because this only works if we have common bases. So we're going to need a better way to solve other types of exponential equations. Like what we're doing right now, like this will not always work. You won't always be able to find a common base, but all of these problems we're giving you, like you're going to be given, it does work. So it's worth checking, or if you see this works, it can save you some time maybe in the future. But for this next one, we have like these are from level 1, these 2 questions, but we have 16 up to x minus 2, and we have 32 up to x plus 3. We want to see what would be a common base that would work for both of these. You might be tempted to try 4. You might be tempted to try maybe 2. The problem with 4, like 4 squared would work for 16. But for example, 4 up to the third power would be 64. So 4 up to something doesn't really give you 32 unless you see like a fraction or a decimal. You might if you're like pretty good, but usually you want to get whole numbers if possible. But so we're going to go back to trying 2. Both of these we're going to be able to write as 2 up to something. So 2 up to the third, if I just plug that in, we saw that was 8. 2 up to the fourth is 16. If you just kind of plug in your calculator, if you don't see that. So we could write this is 2 to the fourth. And we could write 32 is actually 2 to the fifth. Like you kind of just, like I said, you kind of want to just put some of these in your calculator until you get like see it. Like if you watch the Delta Math video, you're going to see that's what they're going to tell you to, or what they're going to show you. They kind of just guess and check a little bit until they find the common base. But here's what we got to do. We haven't seen this yet. We got to be a little bit careful. So when we rewrite this, it's 2 to the fourth, right, for 16. But when I write this as 2 to the fourth, basically you got to multiply what you already had in your power by that 4. So basically, since we have this x minus 2, we're basically going to distribute. And same idea here. This would be 2 up to the 5th, and then you'd have x plus 3. So when you rewrite it as a base, if you already had a power, you're going to multiply it by your new power from rewriting it in a different base. But then we would just simply set these equal to each other. I'm going to just go ahead and distribute. But we would have 4x minus 8 equals 5x plus 15. You could kind of just get everything on the same side. So I'm going to subtract my x's to the right side, my constants to the left side. So I would get negative 23 equals x. Just make sure my math's not wrong. Yeah, so that would be like your answer in delta math. And if you're really like want to check, I mean, you could plug this back in just to see does it work, but you should see it does. Like you would have 16 up to the negative 25th equals 32 up to the 20th. I mean, it's kind of weird when you plug it back in, though. You're going to get like scientific notation, though. Because you're going to get really small answers with these. But yeah, you will see these are the same, but like you're like if you plug them back in, I got like 7.88 blah 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 e to the negative 31. If you have a graphing calculator, ever see like this is, I'll just kind of write, this is what it shows up in my calculator. Like if you have a graphing calculator, you see like a capital E. That's really scientific notation. If you ever see, not that it really matters for what we're doing, but that would be like scientific notation based. That's like how your calculator is showing you that. For this one, so like I said, basically you're just trying to think what up to what power could we get the 16 and what up to what power could we get 1024. I mean, like I said, with evens, a lot of times 2 is going to work. Probably 4 would work. I'm curious, is 4 up to something going to give me 1024? I don't know off the top of my head. If this was your test, no, you could just straight up distribute yourself. I would like if this was a test question though, I would want to see like what you used as your common base though. But yeah, and you're right, Brooklyn. Actually, 4 up to the 5th power is 1024. You also could have done 2 as a common base though. You could have done, I think, 2 up to the 10th power and 2 up to the 4th power as well. So like it doesn't matter what. Sometimes you might be able to use more than one common base because, for example, everything that's base 4 is gonna, like, you could rewrite it as base 2 because 2 goes into 4 kind of thing. But 4 does work for this one. You could do 4 squared. And you could do 4 to the 5th, which I just, like I said, I just kind of put that on my calculator to see, and it worked. I mean, that's what Brooklyn told me. She got that as well. But you also, like I said, you could have written it as 2 up to the 4 parentheses x minus 4 and 2 up to the 10 parentheses x minus 4. Like you would still get the same final answer, but you would get 2x minus 8 equals 5x minus 5, and then just solve this equation. So I'm just going to subtract my 2x. I'm going to add my 5. I would get negative 3 equals 3x, or that would just be negative 1. Level 2, I mean, it's not anything super crazy. I mean, just from what I saw, you're going to get some bigger numbers and maybe some fractions. And we haven't talked about fractions yet, but we'll see. It's not anything too crazy. But for like this first one in level 2, you might be like, well, what the hell? There's 16,807. I mean, they're kind of throwing you an easy, like at least a hint a little bit, because I mean, this is going to have to be 7 up to something. I mean, this is going to be 7 squared. So I know it's going to be 7 up to something for this next one. So just start plugging in some numbers, maybe like 7. I'm going to try 7 to the 4th. Nope, that's only 2,401. Maybe 7th up to the 5th. That's actually it. if you plug 7 up to the 5th power, you get that 16,807. And just for kind of, I mean, if you don't mind, I mean, you would just distribute and you would just solve this equation. 50, 70. I mean, I guess I'll do it really quick. I was just going to say, wait, I did something wrong. Negative 10x plus 4. It's 14 times 5, 70. This. Does this one just not work out nicely? Because you're going to get a, like, I'm just seeing you're going to get a decimal answer at least. Yeah, for sure. Because I just like pulled this problem, I didn't work it out. But maybe you get decimal answers possibly in couple 2 or fraction answers. I'll have to double check that, like how picky it is then. But you would basically get 74 equals 15x. So, I mean, I guess you could just write it as 74 over 15, as long as it didn't make a silly math there. I don't see any mistakes. So, oh, that's negative 10x. No, I did do that. Okay. Yeah. Probably just, I mean, a lot of times, I mean, these aren't going to work out super nice. I mean, okay, if you ever see a fraction, basically you want to remember if you do a negative power, it flips it, right? So anytime you see a fraction, just kind of keep in mind, oh, I'm going to have a negative power is like with my common base. So for example, you almost want to look at the bottom and you like almost just kind of ignore the whole fraction thing for a second if you can. But basically, how could we write 8 and 32 as a common base? Well, I could do 2. Like 2 up to the 3rd power is 8. 2 up to the 5th power is 32. We kind of saw some of those earlier. But since this is a fraction, you're going to do 2 up to the negative 3rd. Because if you put in your calculator 2 up to the negative 3rd, you're going to get 0.125, which is 1/8. So anytime you have a fraction, you're going to have a negative power because that's going to do a reciprocal. Like, or that's what would give you that fraction. And then this would be, oops. And this would be 2 to the 5th. And you would just kind of like solve this. I'm just going to write what you would have, and you could finish solving this if you'd like. But the solving part's not hard. It's really just making sure you get the right common basis. So once you solve this, this would be your answer. Looks like you would also get a decimal for this one. So I think in delta math, though, you're probably going to want to keep your answer as a fraction. Usually they don't like decimals unless it's like a nice decimal, but these do not look like they're going to come out really clean. What did you say? Oh, yeah, that's a big goof. Yep, 5 times 5 is not 50, that is 25. But even still, okay, this one wouldn't work out too bad. It looks, what would you get? Here, I'll just work it out. You would add the 12x, subtract the 25. I wonder if I made a mistake with the other one then. But you would get negative 16. Oh, this still isn't going to work out nice, though. You get 22x on this side. Okay, so yeah, you're going to get a fraction answer. So I would just keep it. They probably want you to simplify it, though. So that would really be, you could do 2 goes into both those. So that'd be negative 8 over 11. So usually in delta math, they're pretty picky about making sure you simplify fractions. Okay, let's just look at one more. Let me know if anyone caught any mistakes. I feel like 22 should be negative. Well, I added my negative 12x to the other side. You could have, if you did it the other way, you subtracted the 10x. I think for my how I solved it, at least I should have a negative. I should have a positive 22. Yeah. And I'll double check like before I upload like my keep to the notes because I feel like maybe I goofed up somewhere. But this one, you're basically, like I said, ignore the fraction for right now. How could you write 5 and 125 as a common base? Oops. Oh, wait, what? Oh. So, I mean, obviously 5, I mean, well, 1 over 5 could be written as actually -1. Like 5 to the -1 is 1/5. And then for this one, I mean, 125, like 5 to the third power is 125. So you could do 5 up to the -3rd power. Because that's what a negative power does. Remember, it flips it over your fraction. Like if you put 5 up to the -3rd in your calculator, it's going to give you a decimal, but it's going to give you what it, like if you turn it into a fraction, it would be this. Like, so anytime you have a negative exponent, remember, it just flips it over the fraction. But then if we just solve this, you would have 12x plus 30. And then on this side, you would have 2x squared plus 16. So you want to get everything on the same side. So I'm going to move everything to the side with the x squared part. But you would have 2x squared minus 12x minus 14. You could factor out a 2, which might make this factor easier instead of doing like group in or something like that. So yeah, what multiplies to -7 adds up to -6. That would be -7 and +1. So you would get x equals 7, x equals -1. So since we have like a quadratic in our exponents, we're going to get 2 answers. So that's one thing in the level 3. A lot of them are, I'm pretty sure pretty much all of them are going to be quadratics. So let me stop.